Hello guys, welcome back to my channel Algorithm Mind. My name is Hasan Khuram and in this channel I teach programming skills in Python, MATLAB and R programming. So I have been producing a series of tutorial videos on how we can actually use the optimization functions in MATLAB. We have a set of optimization algorithms that can we implement on our problem in MATLAB. Now for today's tutorial, I'm going to teach you how you can actually implement particle swarm optimization in MATLAB. We will take a simple problem function that we need to minimize with the help of PSO algorithm in MATLAB. So let's move on and actually see what kind of problem do we have. So this is a mixed integer linear problem. Obviously in PSO we don't have the options of integer programming, but that being said, we have like the function here is to minimize 8x1 plus x2 plus 3x3. So this is the function that we need to minimize, and these are the variables x1, x2 and x3. Keep that in mind, they all will be continuous variables when we come to PSO algorithms. But in my other videos such as genetic algorithm or mixed integer linear programming, where we were able to capture the linearity, or let's say whether these integers were integers or floating point. So these are the inequalities of the function, which depends on the variables that we need to find the value in order to minimize this function. So these are the inequality constraints that we have to impose on our problem, like x1 plus 2x2 minus x3 is greater than equal to minus 14, minus 4x1 minus x2 plus 3x3 less than equal to minus 33, and finally minus 2x1 plus x2 plus x3 less than equal to 20. And finally we have some equality constraint. We have like x1 plus x3 is equal to 5, and we have some bounds x1 should be greater than equal to 0. It means that it has a value of 0 to infinity, and the same goes for x2, and x3 is something like it has a value between 0 and 1. Okay, but in our case it's not binary, it will be a continuous value from 0 to 1. That being said, so let's move on and actually implement that problem in MATLAB so it can be digested by PSO algorithm with the help of particle swarm function. So the first thing we need to do, we actually have to define the inequalities, and you can see that here we have initialized a variable named L, and we have set the coefficients of these inequality constraint in that matrix A. So for example, let's take the example of second equation, minus 4, minus 1 and plus 3. These are the equality constraints. Okay, so we need to change this one to positive 1. Okay, that being done. And for the last equation, we have 2, we have 1 and we have 1. And if you look at the equation 1, the symbols have been changed. That means the positives are being getting negative. So that is being done in order to make this equation justify in the form of like variables should be less than equal to a quantity. So how can we do that? How we can move these variables in the opposite direction and this constant in the opposite direction? By multiplying by negative sign. So here minus 14 will be 14, and this equation will be minus x1 minus 2x2 plus x3 is less than equal to 14. By transforming that equation, then we get the coefficients of first inequality, something like that. Now we have formulated the A. Now let's move on and actually formulate the B. So B are the constants that we have on the right hand side, like 14, minus 33 and 20. So this is how we formulate the equality constraints. So inequality constraints have been defined. In the same way, we will define the equality constraints. For equality constraint, we have like x1 plus 0x2 plus x3 is equal to 5. So this is the equality constraint. So that is being defined here, like 1 for x1, 0 is coefficient for x2 and 1 for x3. Now we have like its constant value also. Here we are setting its constant value to 6.5. Now once we done that, now we have to define the boundaries of these variables, like what are the boundaries of that variable that the PSO algorithm will use to find in order to minimize that function. So we have defined the boundaries by LB and UB, where LB is defined as lower bound and UB defines as upper bound. So we have like 0 0 0, because every where we say that every must be able greater than 0, and we have like the boundaries of upper boundary is something like infinity infinity, and the last one will be 1. Now that being defined, you can skip that. This is for okay. Now that being defined, these are the only things that you need to define in order to define a particle swarm optimization problem. Now you have defined that, defined A, you have defined B, you have defined inequality constraint, you have defined equality constraint, and you have defined the bounds. Let's move on and actually define the options that we can pass as an additional input argument to this function particle swarm. So here we are passing, we are writing option is equal to opti options. Okay, we are calling a function, and within that function we are defining our parameters. Okay, these are the parameters. So first of all, we are defining, we are telling that these options are actually related to particle swarm function. So this is how you define the opti function. So this is how the terminology. The second thing we are defining, swarm size is equal to 20 by first passing a string which contains the variable swarm size, and then declaring its value by after the comma like 20. We are defining the number of particles. So what is exactly swarm size? It specifies the number of particles in the swarm. More particles allow for more broader exploration of the search space, but it requires more computational power. Then we have defining the max iteration value equal to 10. So max iteration defines the maximum number of iterations the algorithm will run. It determines how many cycles of optimization the swarm will go through before stopping, balancing time and solution refinement. Okay, now then the last option is actually display, where we are setting its value to iteration with the string iter. It controls the level of output shown during the optimization process. Setting it to iter displays progress after each iteration, helping you track how the solution is evolving. Now once you have defined the option, next thing you are actually going to do, we are going to call the function particle swarm, and we will pass a multiple input argument. First input argument is actually the objective function, which we have defined at the end, because in MATLAB the function must always be defined in the end. Okay, so this is the objective function, which is this is the notation how you write a function. Output value is equal to function name and what the function takes. So it takes x in the form of array. Then we have defined the objective function 8 multiplied by x1 plus 1 multiplied by x2 plus x3 multiplied by x3. So this is the function, objective function, that this particle swarm function take as an input argument with the help of function handle. So if you don't know about function handles, if you don't know about how you to define functions, I have actually a detailed videos how you can actually define functions or data types of data types in MATLAB. So I will put the link in the description for you. So I will suggest you to go and check out those videos. These are highly resourceful videos. Now here we define three, which is actually denotes the how many variables that you need to optimize in order to get a minimum value. So in our case, we have x1, x2, and x3. Then we will define upper bound and lower bound. So you can see that we have already like upper bound and lower bound. And finally, we will define or pass input argument options which we have created earlier. Now that being said, the last thing we are going to do, we are going to visualize two things. The first thing is are the actual x values, and then the second thing will be the value of function at that specific x value. So this the output of this particle swarm is actually two things: the x values and the value of that function and that specific x value. So let me just go and run this code for you. So actually I'm running a MATLAB online version which has very limited resources. Here it creates an error. You don't have that particular toolbox global optimization in order to run this function. But as you are a student, or you must be have some proper version of MATLAB at your home or at your laptop, you can run that scripts and it will help finally generate the results you want. Okay, and if it still gets an error, you can write down your comments in the video. I will be happy to help you out in that video. Thank you for joining me.